Hi. Thank you, everyone. So I have a little personal ritual where I like to take a speaker selfie. So if everyone wants to, 1, 2, 3, say PyCon. Wonderful. Thank you for having me. I'm very excited to be speaking at PyCon. So as stated, I'm Kelsey. I am the Chief Technical Officer of Sexual Health Innovations. I want to let you know a couple things before we get started. One is that this is a talk covering application security concepts, not specific code. I'm not going to be going into detail about what a cross-site scripting exploit looks like. This is going to be about how you can build an organization and design principles that will protect your users. I will be naming various resources. You don't have to furiously Google them as I talk. If you go to nerd.kelseyinnis.com, the first blog post up there lists all of them. And finally, my Twitter username is on the screen. Feel free to tweet me if you are going to say nice things, and if you're not, don't. I retweet compliments, so. Hi. Okay, so what is Sexual Health Innovations? Sexual Health Innovations is a nonprofit that builds tech to further sexual health in the US. Our flagship initiative right now is called Callisto. Callisto is a trauma-informed, survivor-centered online sexual assault reporting system. Survivors can go to our site, go through a trauma-informed designed interview process to record what happened. They can save that record, and then it's time-stamped and securely saved, and they can take the time to decide what to do. They can report directly to their school or another reporting agency through our site. They also can decide to only report if someone else names the same assailant, or they can just save it as long as they want. They can export it, bring it to someone else as well. Callisto is, specifically, it's an information escrow, and what that means is an escrow is a trusted third party that holds some piece of material, whether that's data, often it's money in a house transaction, some kind of information. Trusted third party that holds it until some specified condition has happened and then it releases it. So in our case, it could be that the survivor decides they want to report, it could be that a match has been found, or it could be never. That's important, and I bring that up because an escrow has a couple things about it that are important, and the main one is that you have a trusted third party, right? So we are being trusted with this data, and we're being trusted to keep it securely, which is a pretty big responsibility. So who built this? Well, the dev team that built it is very talented and beautiful, and you're looking at it. I am currently the sole developer at SHI. I'm a back-end developer by sort of trade and experience. I have no particular security background or training. We're a nonprofit. We're grant and donation funded. You can go to projectcallisto.org if you're interested in becoming part of one of our supporters. But we don't have unlimited resources, right? And I say all that to get across the point, really, that you can do this, that security is within reach to sort of your average Joanne developer, right? This is something that if you know how to develop an app, you can do. And I'm going to talk to you about what we learned in doing that and how you can take those lessons and hopefully apply them to your own projects. You can do this. So, what are one of the things we learned? So we launched our alpha program. We're live on 2 college campuses right now and in the process of expanding to 3 more in the coming months. We launched on our first pilot campuses in August of last year. In July of last year, a very exciting news story happened, which was the Ashley Madison data breach. So Ashley Madison was a online dating site for people who were married to other people. And there was a huge breach where thousands, maybe hundreds of thousands of accounts, their full information was released, including full names, contact information, and financial data. That was a really scary situation, right? And some of the response to that was just like, well, that's what you get when you store really secure, really like sensitive information on the internet. And in some cases, that's, I get that, right? You can't store data on the internet securely. If someone tells you that they can, or that they can promise 100% security for any data, let alone data that is transmitted over the internet, they're selling you snake oil. That's not a possible thing to offer. And your whole approach when you're thinking about security for your app or for your project or for something that you're giving to other people is that you should assume a breach. You should think about not if a breach is going to happen, but what you're going to do when it happens. You want to make sure you have a plan for what you're going to do when it happens, and you want to make sure that you feel really good that you will know if it happens, which is another subtle thing that's important to do. That said, I feel like, as someone who had to field very panicked calls related to the Ashley Madison breach by our customers, I feel that some of the press around this was kind of unfair, right? Because patently, you can store data securely on the internet in that most of us put a lot of very sensitive data on the internet. I mean, raise your hand if you bank online. I do, right? Raise your hand if your doctor uses network-connected devices or records. Many of us do, right? This is a thing that we do. And it turns out for Ashley Madison specifically, the hackers came out and they said, or people who claimed to be the Ashley Madison hackers went to the press and they said, we had been in there for years. We had been in there for years, and we got in there using default passwords for devices off the web and ports that were unsecured, default ports that were unsecured. You want to take anything that an anonymous hacker team says to Vice with like a salt lick-sized grain of salt, but the team behind Ashley Madison actually did come out and say, they said, there was no indication of a software vulnerability. What does that mean? That means that they didn't use code failure or bugs to get that data. It means that whoever accessed that data and released it through the same means that people who had legitimate access accessed it. And whether that was, open doors on the internet, sort of unsecured portals to data, or it was potentially a disgruntled employee, which is a pretty common data breach scenario. The point there really is that with Ashley Madison, you had a really deeply unethical company doing really deeply unethical things with people's sensitive data. And there are ethical things you can do with people's data, and there are ethical things that you should do with people's data. And that's what I want to talk to you about and get sort of a grasp on what those basics are. So, one of the big ones that we're really kind of lucky to do to have in Python is that you really want to start from solid foundations, right? You don't want to be starting from zero when you're building an app for many reasons, but security is one of them. And so language choice and framework choice are really, can be huge tools for you. If you have the opportunity to be working, as I did when I started building Callisto on a greenfield app, you may just be working with whatever's been chosen, but it's a good thing to keep in mind when you're making choices about frameworks, libraries, and languages. For web frameworks and web development, which is what I do, there's a really good resource which is called the OWASP Top 10, the Open Web Application Security Project, OWASP, yeah. So they release regularly the top 10 sort of low-hanging fruit exploits that get people's data released on the internet. And what's nice about that is you can take that and you should be able to look at your framework or your language or your library that you're using, and you should be able to answer for those really sort of low-hanging fruit questions. You should be able to answer, how is my framework going to help me avoid this? And so we chose Django because Django has a really well-developed security philosophy. They have a lot of information about their security on the internet that you can read about. They have good security practices. The flip side for Python, if we're talking about web frameworks for Django is really heavy duty, it's opinionated, it comes with a lot of stuff. If you make a choice instead for other reasons that you want to use something lighter weight, you just need to make sure that you've got those sort of basics under control. Specifically if you're using Flask, there's Flask Security, which is a plugin which is going to cover most of these for you. So, don't make things harder for you than they need to be. Start with something solid and figure out how to get to a place you feel comfortable with before you even start writing code. And that's sort of a common theme that I'll have here, right? Which is about play to your strengths, right? You don't need to become, the leadest hacksaw of all time to do this right. And you should continue to play to the things that you're really good at. I'm assuming if you're in here for a sort of intro basics to security talk, you are not an expert in server configuration. You are not an expert in DDoS mitigation. You're not an expert in load balancing or deployment. Or if you are, you're going to make my life miserable in the Q&A. But, If you are not an expert in those things, it's a really good idea to pay someone who is to do those things for you. And this is, more and more common, especially we're in a world now where it's pretty uncommon to manage your own physical servers, to run your application or your website off of a box in your closet, right? Although that was once a thing. A lot of people use cloud hosting, Amazon Web Services or whatever. You can go beyond that. Platform as a service will handle things like server config, updates, and deployment. That's what we chose. We chose Heroku to do that because all of those things are potentially security vectors or vectors of attack. There can potentially be security holes, and we didn't have the resources to get our knowledge up to where it needed to be for release for that. Eventually we will, right? But it's totally fine to take those aspects that you're not an expert in and find someone who is and give them your money. We also use one other thing that can be a really big asset when you're building something secure. We use a content distribution network, which is like a sort of like a proxy server in front of your regular servers that you're using. It makes your site faster, but it also can, you're drawing on the whole resource of that entire CDN network and company to block you if someone tries to do what's called like a distributed denial of service attack, where they try to take you down by flooding you with traffic. You get that kind of just as part of the package. There's also some basic IP blacklisting and security rules you can do. So this was a really big asset for us. And we wanted to do that because we did know our strengths. And what are our strengths? Our strengths actually are the same strengths that each and every one of you have. Our strengths are an expert level knowledge of our product and our users. And that's a huge asset in building a secure app. Because the first step of where you want to start in designing for secure applications is with what's called threat modeling, which I love the sound of. Whenever I'm threat modeling, I feel very elite. But threat modeling is actually a pretty simple concept, and you already know how to do it, I promise. The concept between threat modeling is you want to know really well for your app, what is an attacker looking for, how will they get it, and what will they use it for? And this is a process that starts early, right? Because you need to know your data model, and you need to know your flow really well. So you want to start thinking about potential attacks early on. For Callisto, we have two kind of unusual threat models compared to your sort of everyday website on the internet. One of them is that we expect that our data will at some point be subpoenaed because people are storing data about crimes in our system. That's a really interesting engineering challenge because making the walls taller and thicker don't really help for protection if the sheriff comes knocking on your door with a court order. So for us, we really needed to think about how can we store our data in a way that we can't provide it even if legally obligated. And what we ended up doing is we store the records in sort of akin to what's called a zero knowledge design. So we ask our users to provide a key, a secret passphrase. We encrypt the record with that passphrase, but we don't store the passphrase anywhere. It means we can't recover it if they forget it, unlike most passwords. But what it does mean is that that data that we're storing in escrow, we can't even read. So if someone comes and asks us for it, we can give it to them, but unless they have that key that only the survivor has, it's unreadable gibberish. Another threat model for us that might not be as true for you is that we expect to see interest from an attacker on a specific individual target. Because most sexual assault is perpetrated by acquaintances or people who know the victim, we know that it's possible that someone who is interested in that record could be someone who knows the user really well and potentially even has access to their machine and to other passwords of theirs. So for us, we needed to keep that in mind when we were designing our system, and I'm going to talk a little bit more about it in a second, but that was around looking at what that attempt would look like, which might be like a brute force attack over and over with like similar passwords over and over and someone attacking from the same machine that the record was created from. And the point here really is that security, like these models, they come out of really deep knowledge of the problem space, which for us was built on substantial user research. And the number one security tip that I can give you is to know your users. A good, strong security practice is actually a strong empathy practice. This is how you keep people safe, is by caring about their data and caring about their privacy. Let's start with a really easy target to empathize with if we're working on our empathy practice. The easiest path in is always going to be through an employee. That Ashley Madison scenario where someone is gaining access through the same means that people who have legitimate access get access. Security needs to be everyone's responsibility, right? Because this isn't limited to your technical employees or to your technical volunteers on a project. There's a great talk that I recommend by Jacob Kaplan-Moss called Minimum Viable Security that talks about how to build these practices into your org. You should go look it up. If I can give you like one quick takeaway from that today, educate people on what's risky and have a clear reporting protocol. And the number one thing really is the big one is password hygiene. Go out from this talk and like go forth and spread the gospel of one password and LastPass, right? Make sure that your coworkers and your fellow volunteers have that set up and have a way to keep passwords safe. Another one is that if you can remove access, you should. So keep your access control locked down. Does everybody need access to production data? They probably don't. Does everybody have access to production data? Probably at some of your companies they do, right? There are simple ways that are process-based and are policy-based to make that safer. A really critical point there that a lot of us are sort of led into is around admin access to websites. So that's a place where you have somebody logging in and making changes to production data. That's a really dangerous vector. There's some things you can do to make that safer. You can change your admin URL is an easy one, right? Put up a honeypot for the default URL to see if someone's trying to get in. You can lock it down by IP. I'm not gonna recommend you do any of those things. What I recommend is that you do what we did, which is we don't run admin in prod. So we have user editable pages that show resources that survivors can get to, and they're edited by my coworkers who are experts in this, unlike me, and it's great to have them edit it. They edit it on staging, and when we're ready to go live, I do a database migration to get it into prod, and so it removes one vector of attack on the production database. The next one is that it's really cold comfort to lock everything down server side if your users are allowed or encouraged to make security choices that expose their data. They're not going to make the distinction between those two things, and you shouldn't either. You want to bolster security with good UI and UX. One of the big ones, again, with this is password strength, right? And so you want to give people the tools to make good choices, basically, is the idea here. In our app, we use ZXCVBN, which is a Python library released by Dropbox, and that uses a much more sophisticated and complicated concept of entropy for strong passwords. There's a famous XKCD where it points out that our standard is it's like 8 characters with a special character and a number, but password with an @ and a 0 is a much weaker password than correct horse battery staple, which, as the XKCD points out, you've already memorized. Check out, if you're interested in this, Lori Craner, who's now the chief technologist at the FTC, leads a lab at CMU about usability and privacy, and it's really interesting. The sort of current wisdom about password strength is really kind of not based on any actual research, so there's a ton of good papers there where they have put people in front of password prompts and seen what they can remember, and they've actually tried to crack passwords and seen what's crackable, so check that out. Another one for us, as I mentioned, is that we were concerned with the possibility that someone could already know someone's password or close to someone's password, an attacker who was interested in that record. So for us, rate limiting was really important. We're not going to let someone sit there and guess forever. There's other things that you can do, and we limit by IP too to even get into the system. There's other things that you can do in terms of if you're concerned that scripting for this is going to be a threat model, that someone's going to write a script to brute force try a lot of passwords, you can exponentially increase the delay between allowed attempts, which will screw a lot of simple scripts. You can add CAPTCHAs to try to verify that somebody who's entering in the password is a human. These are all great ideas, and these are UI ideas, right? They're UX, they're user experience. It's not, network security. You're not sniffing packets, and this is really critical to keeping your app secure. Another thing that was really important to us is that our target users are college students, and college students, we found in our user research that they were much more likely to be using shared computers for various reasons. Might be a computer lab computer, might be a friend's borrowed computer, might be rented from the library. This is something to keep in mind just around sessions. You want to make sure that people are only staying logged in for a long time on your app or your website if they really intend to be. Give them a path to log out. Make sure they expire when they want to. We went pretty strict. We actually do something similar to what a lot of banks do, where we log people out after 10 minutes of inactivity. Another thing that can be really useful is two-factor authentication, right? And that is The factors of authentication are something you know, and that's a password. It's like the one factor that a lot of us see. Something you have, which mostly tends to be phones, but can also be like a physical token, like an RSA token. And something you are, which is biometrics, like your iris or your fingerprint. Two-factor authentication is a great idea. I encourage you to look into it. For our app, it didn't work as well. We found out from user research that students were really unwilling to put a phone number into our app because they were so concerned about their anonymity. Now, arguably, people not using your app are the most secure users of your app in that they have no data with you. But that's always a trade-off you're making, right? So keep that in mind when you're thinking about security improvements. This is like one of the most ironic slides I've ever done. So boundaries are hard. Oh my God. Boundaries between my mic and not my mic. Boundaries between lines on a screen. That was good. The AV guys are funny. So the main point here really is that you want to manage your risk at service, application, and data boundaries. Anytime that you are moving data across services, that you're moving data across applications, check that out. Make sure that you have I don't know what's happening. Make sure that you have a very strong concept of how you're securing things when those boundaries are crossed. Another thing I would recommend, again, if you can avoid crossing the boundaries, avoid it. Don't cross boundaries. We have evaluation data. It's anonymized data that we keep about who's reporting what. It's carefully anonymized, but we want to be able to sort of track what's going on with sexual assault on campuses. We encrypt that asymmetrically, but we don't keep the key online. There's no reason for us to read that decrypted data online. So instead, we keep the encrypted data on our servers. We encrypt it as soon as we write it. And then when we want to decrypt it or analyze it, we pull it offline to an offline box. Think about what actually you need real-time access to. It may be less than you think. Another one is the boundary between your app and not your app. Things like how far away can someone see data on a screen? These are really subtle, but again, this all falls into protecting your users. For us, a really big hard one for that is that we deliver reports to school admins if survivors want to report. We don't want to violate any of our guarantees about subpoenas in that delivery, right? Can we get the sound lowered? It seems like it's very loud and people are having trouble. No? We're working on it? Okay. We didn't want to, even though someone has just chosen to report, it doesn't mean that we want to violate those guarantees about subpoenas. So what we do is we encrypt the records that are ready to be reported with a school's public key. That's asymmetric. So we have the public key to encrypt it, but we don't have the key to read it. So we've gone from one encrypted blob to another encrypted blob, and we deliver that encrypted blob. Now, those of you who are astute and have used PGP before or worked in university context are probably dying inside, because what I'm describing is teaching regular human beings to use PGP. And that is very difficult, right? There's a ton of UI concerns there. Now, there's lots of things we can do and will do to make that easier, but what I really want to do is think about what are our admins doing after they get our reports. Now, technically that's not my problem, right? I'm like, oh, kick it over the fence. I don't care anymore. But if someone using our system, their data has been released by how it's delivered at the end, I don't feel comfortable with that. So our admins actually are taking these reports, they're decrypting them, and they're putting them into their student management systems. My ideal security solution to this would be to integrate directly into the student management systems so that we don't have that extra human error step in between. So integration can be a powerful security tool. Finally, another really big one for me that I learned from this, because we are doing somewhat complicated things with encryption, no new crypto, no new crypto, no new. Don't do it. Use respected crypto libraries, use crypto libraries ideally that have been audited. There's a great talk about the state of crypto in Python that can tell you more about this. We use Pineapple, it's pronounced salt, which is like, whatever, I get it. NaCl, which is like something cryptography library, but it's like the, elemental definition of salt. Anyway, it's called salt. It's based on a C library that's really widely used, written by really well-respected people. We use GNU-PG, which has also been used forever. Use stuff that's already been well-tested. You do not want to be the first exploit of anything. Like, that is not worth the shiny, I promise. There's an EFF post about what you should look for in a security audit, which I recommend. They say 3 things. This is what you should look for if you're looking for audited code. You want the audit to be recent. You want the code to be open source so you can verify that what was audited is what you're using. And you want a clear and detailed design document. Now I say that because you're going to want those things too. So we have all three of those. We have two of those things. We have the first two. We're open source and we've been recently audited. I would love to have a clear and detailed design document. Our code is open source. If you're interested in contributing and helping me make that, please let me know. Your security story is a huge part of user trust, so you really just want to keep it simple. Finally, the last thing, I can go back to a theme from earlier in the conversation, which is pay someone smarter. A penetration test is when you have someone take your running application or a clone of your running application and try to get into it, and they tell you what they found. It's one part of a formal security audit. It can include assessing architecture, interviewing your staff, doing things like trying to phish your staff. This is a great use of resources, really it is. It feels hard when you're pinched, but if your data is sensitive enough, you should get someone who really knows how to break a system, trying to break your system. Another thing that you can do that's an interesting variation of this is called a bug bounty, and that's where you say, hey, hacksaws, if you find a bug in our app and you tell us first, we'll give you a reward, whether that's acknowledging them, paying them money. This is really widely used by really big companies, including the military. There's now services that will facilitate that for you. The point there, too, is that you really do want a disclosure program. So whether you run a formal bug bounty or not, give people a way to let you know if you've gotten something wrong, instead of letting the internet or the bad guys know. And this can be as simple as putting up a security@yourproject.org on the website, and that's really critical. So finally, thank you so much for listening to me. I want to make sure I give thanks to my advisory board, which helped me with this hugely, because again, I was starting from very little. Lee Honeywell, Sophie Haskins, Sina Barham, Selena Deckelman, Chris Valasek, and Don Bailey all were huge helps with security. Also friends of the project, Ben Hughes, Jacob Kaplan-Moss and his team at Heroku, and Miko Govender at NCC Group. I have all of the resources on that poorly line-broken URL. It's nerd.kelseyyinnis.com. And if you're interested in the project, please go to www.projectcallista.org. I'm out of time, but I'm happy to answer questions that anyone has off of stage. Thank you.